Good morning, students.
Good morning, sir.
So let us we have discussed in the last class that is the streamline, path line, strip line. Today I am going to discuss that is the some more example that is the today the last class of this chapter related to the circulation, a stream function, potential. All these we will discuss. So write down the first problem. All of you please write down. In a flow field, please write down the question and sit with the calculator, pen, paper. In a flow field, the velocity vector is given by capital V equal to 4xqi 4xqi minus 10x square yj minus 2x square zk
So फिर से भी
ij.
repeat करिए.
Just repeating. Capital V, that is the velocity vector equal to V equal to 4xqi minus 10x square yj minus 2x square zk, where I, J, K are the unit vector along x-axis, y-axis, z-axis respectively. Find whether it is a possible case. Find whether it is a possible case of a steady incompressible flow. A steady incompressible flow. Full stop. If so, find the velocity and acceleration of the fluid particle. Find the velocity and acceleration of the fluid particle at coordinate 1, 3, 3. Means x equal to 1, y equal to 3, z equal to 3. First, you have to check is it a steady incompressible or not. All of you written the question or not? V equal to 4xqi minus 10x square yj minus 2x square zk. Check it is a steady incompressible or not. If it is a so means a steady incompressible, then find out velocity and acceleration at any point 1, 3, 3. So let us see in the given velocity vector, that is the velocity component along x-axis, that is the I vector, u equal to 4xq, v equal to minus 10x square y, and w equal to the minus 2x square z. Is it correct or not? Is it correct?
Yes, sir.
Yes, sir.
U, v, w, that is the given. Then you have to check the continuity equations. Del u by del x plus del v by del y plus del w by del z equal to 0 or not. If 0, then satisfied. To find out del u by del x, so del u by del x is how much?
12x square
12. Correct. Del v by del y,
minus 10x square
correct.
Right.
Del w by del z,
minus 2x square
Correct. So satisfy the equations.
Continuity
Am I right or
equation.
not? Yes. So continuity equation is satisfied. Then you have to find out the velocity and acceleration. So we know u v w. So square root of the u square v square w square, that will give you the resultant velocity, acceleration, and v at the point 133. That's all that will come out. Acceleration. What is the acceleration along x-axis? Tell me. Equation. Just you tell me the equation first. Ax, Ay, Az. So Ax equal to del u by del t plus u into del u by del x plus v del u by del y plus w del u by del z. Am I right or not? Local plus convective, that give the acceleration along x-axis. So tell me the Ax, how much you got it? Ax equal to how much? Acceleration along x-axis. Just you tell me. Yes, tell me. Acceleration along x-axis.
360.
No, no, not find out first that you got.
48x
48 x to power.
5.
Tell me. X to power.
5.
Correct. So ax equal to the 48 into x to power 5. See, u is given and del u by del x will come out 12x square. And u is given 4x3 x to power q minus, that is the v is given 10x square y, but del u by the del y equal to 0. There is no any term of the y in the u, so that will become 0. Similarly, in the del u by the del z is 0, and no term for the time, so local acceleration del u by del t is also 0. So ax equal to the 48 into x to power 5. Correct. Similarly, find out the ay. All of you getting or not getting? If you have any doubt, then ask me. So ay equal to, that is the local del Vy del t plus convective. U is replaced by the simply v. U into del Vy del x plus v del Vy del y plus w del Vy the del z. That's all. U v w is given. Tell me the ay, how much? Acceleration along y direction is how much?
200x cube.
Yes, how much?
200x cube.
No, no. Again, check it, please. 20 into x to power 4 into y. Anybody got it? Just that is the derivation of the Vy del x del Vy del y del Vy del z plus del Vy del t and u vw, that is a multiply. That's all. Check it. Anybody got it? 20 into x to power 4 into y. U is given 4x cube. Del Vy del x will come out minus 20xy. Am I right or not?
Yes, sir.
V is given minus 10x square y. Del Vy del y will become minus 10x square. Is it also correct or not correct?
Yes, sir.
Minus 2x square z into del Vy del z is 0. And del plus del Vy the del t is also 0. Is it correct or not correct? Last I have written local that is the acceleration del Vy delta t. So you got it 20 into x to power 4 into y. Is it correct or not?
Yes,
From
sir.
the first, got it, na?
Yes, sir.
Yes, sir.
Minus 8, minus 80 into x to power 4 into y plus 100 x to power 4 into y. That will come out. Okay. Az is how much? Tell me. Az, Az equal to how much? Yes, tell me Az.
Minus 12x to the power 4z.
Yes, yes, not that is the clear. That is sound is not clear. Yes, tell me.
Sir, minus 12x to the power 4z.
Correct. See, we got the ax, ay, az, then substitute the 133. We are interested to find out the resultant acceleration at coordinate 1, 3, 3. And resultant is a root under that is a square that will give. You might be know. So this is our interest. Is it correct? So Hello, question second you have written or not? It is by the that is the our I by that is the muted perhaps. Check whether the flow defined by the stream function psi equal to 2xy is irrotational. Have you written or not written?
No, sir.
Oh, sorry. I it why that is the muted. Please write down. Check whether the flow. Yes, please write the question. Check whether the flow defined by the stream function psi. Check whether the flow defined by the stream function psi equal to 2xy. Psi equal to 2xy is irrotational. Check whether the flow defined by the stream function psi equal to 2xy is irrotational. If so, determine the corresponding velocity potential. If so, determine the corresponding velocity potential. Here psi is given. First you have to check irrotational or not. If it is irrotational, then you can find out the velocity potential. So psi is given, then do you know the how we can you should check the irrotationality? So for irrotational check, we will find out the divergence of the velocity vector v. So write down del v equal to del v equal to under determinant first row I j k, second row del y del x del y del y del y del z, third row u v w. This is the velocity component. So del v, this is the formula for the del v. V is the velocity vector equal to the under determinant two vertical lines I j k unit vector हो गया फर्स्ट रो, सेकेंड रो del y del x del y del y del y del z, third row velocity component u v w. From here find out the determinant. How much is the u and v? Do you know the relations? A stream function and velocity. Gradient of the stream function equal to the velocity component along x direction and y direction. So u equal to the how much? Del psi by the del y. Am I right or not?
Yes, sir.
Minus 2x.
U equal to is del psi by the del y. So that will come out 2x. Am I right? And v equal to v equal to minus del psi by del x. That will come out minus 2y. Am I right or not? Just you tell me, are you getting or not getting? हेलो, आप लोग रिप्लाई नहीं करेगा तो कैसे होगा? बोलो, आर यू गेटिंग और नॉट गेटिंग? A stream function we have given in the note also. So uv, then check the del v. Del v is how much? Formula is I have given determinant of I j k del y del x del y del y del y del z u v w. W is 0. No component of the velocity w we can find out from the stream function and put on that. So u equal to 2x, v equal to the minus 2y, w equal to 0. Find out the determinant that will come out. How much determinant value? Yes, tell me, determinant value is del v of the determinant equal to 0 or not?
Yes, sir.
Del v equal to 0. So flow is irrotational. Hence velocity potential exists. Always remember, flow is irrotational, then only velocity potential or potential will exist. So flow is irrotational, hence velocity potential exists. Then our next aim is find out the velocity potential. I have given the relation of the velocity potential. You have to find out the relations potential phi. You have to find out the phi. So for total derivation of the d phi equal to del phi by del x into dx plus del phi by del y into dy. And what is the del phi by del x? Hmm.
minus u.
Del, del phi by del x equal to nothing but that is the u. And del phi by del y is nothing but v. And u is nothing 2x. And v is minus 2 by. So d phi equal to 2x dx minus 2y dy. Am I right or not? D phi equal to 2x into dx minus 2y dy. Is it correct or not? Tell me. You got it or not this value?
Sir, in
Yes.
some books it is written del phi by del x is equals to u, while in some it is written del phi by del x is equals to minus u. What should be taken like that on that?
Just tell me. What is your opinion? What is the value? Yes, tell me.
Sir, in some books del phi by del x is taken as u, while in some others del phi by del x is taken as minus u.
No, no. See, I am telling. For the stream function, it is the reverse. For the potential, it is the same.
Yes, sir. But in some it's written that the negative of the del phi by del x is equals to u.
No, no. Negative for the both. That is the for velocity u d phi by dx equal to the minus u d phi by dy is minus v. Am I right or not?
Yes, sir.
Both is minus or both is plus. Any one you can take, either both minus or both plus.
Yes,
Not
sir.
one.
That was yes,
Is
sir.
it correct or not?
Yes, sir. Yes, sir.
See, you might be know that is the concept of that the potential that is that they are considering from that is the mathematically either you can take that is the like coordinate system first and third accordingly they have considered and some ideology these are the always that is the going inwards, so that is the minus. But in generalized book taken both plus, so you can take either both minus or both plus, that is the correct. But you must mention in the examination we have considered the potential in minus sense. Am I right?
Yes, sir.
But
Similar fashion is with the stream function also, sir.
no, a stream function is one plus one minus, not both
Yes, sir.
minus or
Yes,
yes.
sir. Some books have taken u as positive and others have taken u as negative, like
No,
that.
no. Every book use u equal to the del psi by del y and v is minus del psi by del. Otherwise, not satisfy the continuity equation. Boy, I have shown you how you can satisfy the equations. There is some relations in potential. That is the you might be seen that is the satisfy the some equations in also here continuity equation satisfy, otherwise not satisfy. You can check yourself, go through the textbook and read it on what basis or see the my note. Laplacian equation may be satisfied by using both minus both plus. You may take the minus right side, that will become zero or something other. In continuity equation will not satisfy that is the correctly. So
Okay,
see,
sir.
so phi equal, so d phi equal to the 2x dx minus 2y dy. Integrate it, that is the phi will become x square minus y square plus some constant c. Am I right? Write down the third problem. Write down the third problem, please. Find the discharge. Find the discharge between the streamlines. Find the discharge between the streamlines passing through 1, 2. X is 1, Y is 2. 1, 2 and 2, 2, 2, 2, x equal to 2, y equal to 2. So passing through 1, 2, 2, 2. If the velocity potential for the flow field, if the velocity potential for the flow field is given by, if the velocity potential for the flow field is given by phi equal to 3xy, phi equal to the 3xy, potential is given phi. Hello, you have written the question or not? Hello.
Up to v is equals to 3y.
Fine. Question have you written or not? Find the discharge between the streamlines. Have you written or not written?
Phi is equals to 3xy पे आप mute हो सकते हैं.
Phi equal to 3xy. That's all. Full stop. Bus. This is the only question. Find the discharge between the streamlines passing through 1, 2 and 2, 2 if the velocity potential for the flow field is given by the phi equal to the 3xy. That's all. This is the only question. Acha, just you tell me how many classes I have taken. Have you remember anybody? Saurabh? Acha, okay, don't worry. Just I am calling the attention, roll call, just you tell me. Roll number 1, please call the roll call today and try to solve the problem at the same time. Just I am checking it. Roll number 1, roll number 2, 3, 4, 5,
Present, sir.
6.
प्रेजेंट सर.
क्लास अभी लीव मत आप लोग करना है, प्रॉब्लम हम लोग का चलते रहेगा. जस्ट इन मीन पीरियड आई एम कॉलिंग द अटेंडेंस. इज इट करेक्ट? डोंट लीव द क्लास. रोल नंबर 7, 8,
Present, sir.
9, 10, 11,
Present, sir.
12, 13, 14,
Present, sir.
15,
प्रेजेंट सर.
16, 17,
17 present, sir.
okay, 18,
Present, sir.
19, 20,
Present, sir.
21, 22, 23, 23,
Present, sir.
20
23 present, sir.
23 na?
Yes, sir. 23.
Okay, 24, 25,
प्रेजेंट सर.
26,
प्रेजेंट सर.
27, 28, 29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Present, sir.
35,
Present, sir.
36.
Present, sir.
So see, in the problems that is I have given, which you might be the solve. So u equal to, can you find out first the u and v? And from there we can find out the stream function del psi by del y, del psi by the del x. And relation with the stream function, and that is the discharge, we have also discussed in the class. Is it correct? So you may continue. Yes, continue the attendance also. Roll number 37, 38,
Present, sir.
39. Yes, sir,
Present,
38.
sir. 39 present.
Okay, 40,
40 present, sir.
41,
41 present, sir.
42,
Present, sir.
43,
Present,
four-
sir.
44, 45, 46, 47, 48,
Present, sir.
49,
40.
49, 50, 51, 52, 53,
Present, sir.
53.
Yes, sir. 53.
Okay, 54,
Present, sir.
55,
Present, sir.
56,
Present, sir.
57,
Present, sir.
58, 59,
Present, sir.
59.
Yes, sir. Present.
Okay,
Sir, roll
60,
12 present, sir.
60.
माइक काम नहीं कर रहा था सर.
Roll number 60.
Sir,
60.
60 present.
Sir, 59
60 present.
Okay, 61.
61 present, sir.
Okay, 62, 63,
Present, sir. 63.
64, 65, 66.
Present, sir.
60.
66.
Okay, 67, 68,
Present, sir.
68.
Sir, present.
Okay, 69.
69 present, sir.
Okay, 70,
70 present, sir.
71, 72.
Present, sir.
72%. Okay. So let us see. We will discuss the numerical first. So u equal to the, please write down all of the question I have already given. Then we should continue the attendance. U equal to the minus del psi by the del y is also equal to the del phi by the del x. And see, phi is given 3xy. So phi is given, then del phi by del x will become 3y. So u equal to the minus del psi by the del y equal to the del phi by del x equal to the 3y. Next, v. V, that is the velocity vector along the y direction, is del psi by the del x equal to the del phi by the del y. So phi is given, it will become 3x. So u equal to the 3y, v equal to the 3x, or minus del psi by the del y equal to the 3y, del psi by the del x equal to 3x. So after integrations, del psi by the del y, that will become psi equal to the minus 3y square divided by the 2 plus c, where c is a function, c is a constant. Always remember, c is a integration constant, and which is a function of x. Always remember, because we are integrating with respect to the y, so it is, and psi is a function of xy. So in constant integration is a function of reverse. So psi equal to the minus 3y square divided by 2 plus c is and this constant integration is a function of x. Again, second term, del psi. So this del psi by the del x. So this is the function of the x c. So c is nothing but the fx. And differentiate this fx del psi by the del x equal to the f dash x. And this del psi by the del x is given 3x. So psi will come out psi equal to the minus 3 by 2 y square plus 3 by 2 x square plus some constant c1. And our interest to find out discharge between the two streamlines that passes through the coordinate 1 and 2 and second points that is the 2 and 2. So phi, so that is the phi is transformed in the term of the psi, means potential is transformed in the stream function, and relation between the discharge and stream function psi is, so discharge q equal to the psi 1 minus psi 2, and psi 1 that is the passing through the 1 2 and 2 passing through the 2 2. So that will come out, that is the minus 6 plus 1.5. So discharge will become minus 4.25. So this is the your discharge relations we have already discussed. Am I right? Then continue the attendance. Roll number 73.
सर 45 का छूट गया था चैट बॉक्स में लिखे हुए
Okay.
माइक
रोल
नहीं
12 का भी छूट गया था सर।
Hello, please don't
Mic बंद
discuss
था।
about those who have left. First, we will consider that is the which we are going to call. Roll number 73, 74,
74 present, sir.
70, okay, 75,
75 present, sir.
okay, 76,
76 present, sir.
77, 78, 79,
present sir
80,
80
sir
present, sir.
70
80, okay, 79 present, 80 present, 81, 80, okay, 82,
Present, sir.
83, 83, 84,
present sir
85, 85, 86,
present sir
87,
87 present, sir.
88, 89, 90, okay, 90, 91,
91 present, sir.
92, okay, 92,
Present, sir.
93,
Present, sir.
94, 95,
Present, sir.
96. All of you stay with us. I am not that is the living. After the attendance, again we will call the last round after the one problem. Is it correct? 96, 97, 98,
present sir
99, 100,
Present, sir.
101,
present sir
okay, 102,
Present, sir.
103,
present sir
okay, 104,
present sir
105,
present sir
106, 107, 108.
Present, sir. 108.
107 present, sir.
Okay.
107.
Please write one more problems. Then I will continue the attendance, please. All of you, please write the question. So that show that a small u equal to 3x plus y. A small u equal to 3x plus y and v equal to a small v equal to 2x minus 3y. 2x minus 3y are the velocity components of a fluid flow. Full stop. If so, find the circulation around x equal to plus minus 2, and y equal to plus minus 2. Coordinates are given that make a geometry, and that geometry you have to find out the circulations. X equal to plus minus 2 and y equal to the plus minus 2. All of you written the question? Yes, continue the attendance. Roll number 109,
Present, sir.
110, 111,
Present, sir.
112,
Present, sir.
113,
Present, sir.
114,
Yes, sir.
115, 116,
Present, sir.
117,
Present, sir.
118,
Present, sir.
119,
Present, sir.
120.
Present, sir.
120 तक है और more
Sir, till 122.
till 120 ने.
122.
122, sir.
Oh, okay. Roll number 121,
Present, sir.
122.
Present, sir.
Okay. So first round I have completed the attendance. Then first you solve this problem. Then we start from the one. So see, our velocity components are given. U that is the 3x plus y, v equal to the 2x minus 3y, and that is the geometry along which we have to find out the circulations. We have discussed the circulation is nothing, that is the contour, that is the closed integral. So it is a contour of the given geometry. So see, x equal to the plus minus 2, y equal to the plus minus 2. From this, that is the coordinate system, you should get that is a rectangle, and rectangle, that is the center is 0. And let us start from that is the coordinate system, bottom right, that is the a equal to the 2 minus 2, top bottom, that is the b, or any, that is the 2 2, then minus 2 2, and last that is the minus 2 minus 2. So this is a rectangle. Am I right or not? From the given coordinate system you get that is a rectangle. So this first we will check is it satisfy the continuity or not. So this is the two-dimensional only velocity are given u and v. So check the continuity equations. Del uy the del x plus del vy the del y equal to 0. U and v is given you might be get 3 minus 3 equal to 0. Am I right or not?
Yes, sir.
So see, so these velocity components satisfy the continuity equations, means they are velocity component of the fluid flow. Then we have to find out the circulations around the rectangle whose coordinates are given. Whose coordinates are given. You might be draw the coordinates. So circulations, that is the omega equal to the contour, that is the closed integral of u dx plus v dy. Am I right or not? This thing that is that in theory we have discussed, and also I have given the notes. So omega, that is the equal to the closed integral of the u dx plus v dy. अब see, we will take from one straight line and write this, that is the integrations. So integration of u dx plus v dy for the line AB, u dx plus v dy for the line BC. For third, that is the integral is u dx plus v dy for the line CD, plus fourth line u dx plus v dy for the line DA. So close, that is the integral is completed. This is the meaning of the closed integral, and we have written that is the 4 integrals for each integral for each line. That's all. It is completed the contour around which we have to find out the circulations. Then question is, what is the U? U is given, V is given. Is it correct? Interesting thing is that X, so see, first A for AB. So see, this is the very interesting thing. You must take the care about these things. So there are, that is the 4 lines. First lines for integration of the AB. According to the my, that is the my marking, AB is right side the vertical line. BC is the horizontal line. CD is the left side, that is the from origin is the vertical line, and D2 is again horizontal line below the center. So A, B, B, C, C, D, D. You may mark from the any point, that is not a matter, but rotations, but starting to end is the move the anti-clockwise. This is the very important. Not you should write the arbitrary. AB is vertical upward, then CD is again vertical upward. No, this is not possible. Either it is AB start the vertical direction, then CD definitely come downward, but so it moves, that is the anti-clockwise. So see, for the line AB, this is the, for in my case I have chosen that is the vertical. AB equal integration of 3x plus y into dx plus 2x minus 3y into dy, u plus v, ux plus v dy. See, x equal to the 2, x equal to the 2 in the first line. Equation of the line for the coordinate system AB, line is x equal to 2 or x minus 2 equal to 0. So dx, so x equal to 2, then dx equal to 0. Always remember, 3x plus y into dx, 2x minus 3y into dy. But the AB line x equal to 2, then dx equal to 0. So first term for the line AB, dx will 0, then rest is the 0. And second term will be 2x minus 3y into dy. And x is given 2 y, that is the unknown, you have to differentiate with dy. So 4y minus 3y square by 2, and AB line vertical varies from minus 2 to 2. That will come out 16. So this part is some importance. Otherwise, you are not able to complete the circulations. Again, I am repeating. So from given, that is the coordinate system, x equal to plus 2, x equal to the minus 2. Means from the origin it go right side and left side. Similarly, y-axis from the origin top plus 2, bottom minus 2. Obviously it will come out. It, and from these coordinate system you may draw a rectangle whose coordinates are first quadrant, which I have marked, that is the B 2 2, second quadrant minus 2 2, which I have marked C, third quadrant, that is the which I have marked D minus 2 minus 2, fourth quadrant, which I have marked A 2 minus 2. All of you getting or not getting, please tell me. This is the very important circulation. Any doubt, then ask me. So this is the, let us suppose I have marked the A, B, C, D, and you have to integrate along all these lines in systematically anti-clockwise. In second case, that is the horizontal line, y equal to the 2. So dy equal to 0. Second part is 0. First part only exists. Similarly, for the third, x equal to minus 2, dx again 0. Fourth again, dy equal to minus 2. So dy equal to 0. In this way, you can find out and you may see from the book and practice it. Is it correct? So see, just I try to complete the attention. Those who were absent. Roll number 1,
Present, sir.
2,
Present, sir.
3,
Present, sir.
4.
Present, sir.
Roll number 7,
Present, sir. 7.
9, 10,
Present, sir.
12,
Present, sir.
13,
Present, sir.
16, 19, 20, 21,
Present, sir. 21.
okay, 22, 24, 27,
Yes, sir.
Yes, sir.
27,
Yes, sir.
Yes, sir.
28, roll number 37, roll number 44, 45,
Present, sir.
46, 47, 49, 50, 51, 52, 58, 62, 64, 65, 67, 71, 73, 77, 78,
Yes, sir.
Present, sir.
Present, sir.
78, okay, 83, 85, 88, 90,
Yes, sir.
94,
Yes, sir.
96, 97, 98, 106, 107, 110, 115. So let us see, this is the all about that is the problem which I have discussed today. You may practice from the book. So circulation, stream function, potential, all these we have discussed. In the next class, we will start a fresh chapter. Okay, thank you. Any query? Any question?
No, sir.
Okay, thank you.
Roll 73 present.
Thank you, sir.